Okay, today we're going to do 5.2D3, applications of trig functions and identities. So we're going to be looking at some real-world problems, and we're also going to be looking at how to use our calculators for these. First and foremost, quick review of your identities. They're over there as well on the sideboard. We have our reciprocal identities. Really, you only need to memorize your first 3 reciprocal identities, because once you have your first 3 reciprocal identities memorized, you can just reciprocate them for the other 3. Okay? And then we have our quotient identities. Sine over cosine is tangent. Cosine over sine is cotangent. How do you remember which one to use? Co goes with co. So cotangent has cosine on the top. Pythagorean identities, please read page 504. I'm not kidding, do it. Because it gives you the justification for these, and it's a really good example that you need to read. Okay, now, the first one, sine squared theta plus cosine squared theta equals 1, is going to be your most used Pythagorean identity. But you still need to know the other 2. So here, again, if you memorize one of these, you automatically have the other. Tan secant, cotan cosecant. Okay, so they still have that relationship with the function and the cofunction. Okay, and again, those are over there on the sideboard. Now they just totally shot Kevin in the eye with the laser. All right, so now using our scientific calculator, we're going to evaluate the functions. So the first one's easy, it's cosine. But do I want to be in radians or degrees? How do I know degrees? Because it says degrees. All right, so I would put your calculator into degrees and find the cosine of 48.2 degrees. And what do we get? Well, that's just a weird answer. So we're going to go 0.66653 because we never want to leave a 666 hanging out. All right, cotangent 1.2. Notice the lack of a tiny circle. There's no degree symbol. If there's no degree symbol, it means you're working in radians. So everybody switch your calculator over to radian mode. Wait. So how do we find our cotangent? There is no cotangent button. As a quick side note, the following 2 mean something very, very, very different. There's this button, and then we're going to use this function. Those 2 mean very different things. First of all, this first one never has a theta in it. What goes in there, and that's a very, very common mistake, is to use tan to the -1. That means the inverse of the tangent. So that means that if I give you the ratio, opposite over adjacent, and I say, here's your opposite over adjacent ratio, now find me the degree using tangent, that's what you use. You use this first one to find how many degrees are in my angle. The second one says find the tangent ratio of an angle. So I have angle theta. When I do tan theta, that gives me the ratio of opposite over adjacent. Well then, when I raise that opposite over adjacent to the -1, that reciprocates and gives me adjacent over opposite. So it's really important that you know the difference between these 2 calculator functions. Okay? So that being said, cotangent of 1.2, we're going to enter the following into our calculator. I want you to open a parentheses. The reciprocal function for cotangent is tangent. So we're going to take the tangent of 1.2. Now your calculator should open a parentheses for you. You want to go ahead and close that first parentheses that it opens for you. Okay, right there. And then you also want to close the beginning one that you added. And once you close the beginning one that you added, raise it to the -1 power. That's how you're going to enter it into your calculator. So I want everybody to do that now. And as you do that, you should find that it's 0.3888. Up next we have sine of 72.8 degrees. Again, this one's in degrees. So make sure your calculator says degrees. And then plug in. And it is 0.9553. Cosecant of 1.5 is measured in radians because there is no degree symbol. Now, cosecant is the reciprocal of which function? Cosecant is the reciprocal of sine. So that means that we're going to open parentheses. We're going to take the sine of 1.5. Then once we have the sine of 1.5, we're going to raise it to the power of -1, or we're going to reciprocate it. And what do we get?
1.003.
I took it out to 2.5, but honestly 3 is good. So 1.0025. All right, let's look at another type of problem. Here I have a triangle. In my triangle, I'm given the angle. My angle is 34 degrees. I'm given a hypotenuse. My hypotenuse is 220 inches. And now A is the side that is opposite my given angle. So which one of my trig functions deals with angles, opposites, and hypotenuses? Sine, or if I wanted to be really fancy, what else could I use? Cosecant. Good. Let's not make this more difficult than it has to be. We're going to use sine. So the sine of theta equals opposite over hypotenuse is our formula. So now let's plug in what we have. We have our theta, it's 34 degrees. So the sine of 34 degrees equals my opposite value, well that's my variable A, over my hypotenuse, which is 220 inches. All right, so everybody put your calculators back to degrees. What's the first thing that we have to do? First thing we're going to do is take the sine of 34. So I want everybody to take the sine of 34. Do not clear out your calculator. So your sine of 34 should have given you 0.5 something something something. So now how do I solve for A? I multiply by 220 inches, and I find that A equals 123.02 inches. You have to remember your unit of measurement. I'm going to remind you guys about this every day, because I can't express to you enough how important it is. Because if this was a quiz question, you would get a point here for setting up your relationship. Sine of 34 degrees is A over 220 inches. You would get a point for finding the correct answer, because you pushed the correct calculator buttons. Yes, I'm giving you a point for pushing buttons on a calculator. And then your third point would be to remember your unit of measure. Okay? Bless you. All right, number 6, find the value of the acute angle. So now I have the tangent of beta equals 4.6252. What does that mean? This means that I have taken my triangle, and tangent is opposite over hypotenuse. So whatever my opposite and my hypotenuse were when I took opposite divided by, tangent is opposite over adjacent. So whatever my triangle said, when I punched in opposite and I divided by it whatever the adjacent was, it reduced to 4.6252. So my opposite over adjacent ratio is 4.6252. How many degrees are in my tangent? Okay, so now we have to solve for beta. This is where we do inverse tan. Just like with addition, what did we do to undo addition? Subtraction. With multiplication, what did we do to undo multiplication? Division. We did the opposite operation. Well, the opposite operation of tangent is inverse tangent, tangent to the -1. So that means that beta equals the inverse tangent of 4.6252. Now, it's asking us to find this in degrees, so make sure your calculator is in degree mode. And tell me, how many degrees does beta measure?
77.8.
Good.
The 10 -1.
77.8. Don't forget your degree measurement. Good? Questions? So again, we're going to do it with the cosine of theta equals 0.4112, but this time we want to work in radians. So everybody switch your calculator over to radians. Again, how do you undo cosine? Inverse cosine. So that means that theta is going to equal the inverse cosine of 0.4112. So what is my measurement for theta? .147
I tried it and you said domain error.
radians. All right, so today we're also going to talk about angles of elevation, angles of depression. One of the things that you have to keep in mind is that it always revolves around the horizontal line. So no matter what the little diagram is, the first thing that you need to identify is where is your horizontal line? Whose perspective are we looking from? Because looking from this guy up here in the building versus looking at this guy down here in the car, those are two completely different perspectives. So an angle formed by a horizontal line and the line that's above you. So if you're looking up, it's an angle of elevation. The angle formed by looking down, that's an angle of depression. Okay, you guys already know that. You should also know that here, this line is horizontal. This line is horizontal. That makes them parallel. So opposite interior angles are congruent. Yes, they are. They are congruent. Okay, so what does this last sentence mean? Have you guys ever seen maybe somebody just bought the house next to you and they're having it surveyed, or you've seen the construction crews and they have those little tripods with little boxes on top? They're doing basically horizontal angles of elevation and depression, but they're doing it vertically. So they're going to do something like the following problem. So here the irregular blue shape is a pond. The distance across the pond A is unknown. So there's your distance across the pond A. And it wants to know what is A. Now it's going to give you an angle. It's going to give you a measurement. Now this is my adjacent measurement to the given angle. And my unknown over here is the opposite. So which one of my trig functions do I use when I have an opposite and an adjacent? Tangent. So we're going to use the relationship that tangent theta equals opposite over adjacent, and we're going to fill in what we know. Well, we know that theta is 24 degrees, so that means everybody needs to have their calculator in degree mode. So the tangent of 24 degrees equals, the opposite of that angle is my variable, and my adjacent value is 750 yards. So again, we're going to do the same thing here. You're going to take the tangent of 24, and then you're going to multiply it by 750 yards, and we find that the value of A is 0.92 yards. Okay, before you place your unit of measure, make sure that you remember what it is we're talking about. So here, a degree symbol wouldn't make sense. The word radian wouldn't make sense, okay, because we're looking for a measurement. The length of A is a unit of length. So here we're working in yards. Questions? All right, here we go. A building is 21 meters high and it casts a shadow 25 meters long. All right, little picture shows that. Find the angle of elevation of the sun to the nearest tenth of a degree. So now they want us to find the measurement of theta. So here 25 would be considered my adjacent. 21 would be considered my opposite. So that means that I'm again working with tangent. So the tangent of theta equals opposite over adjacent. All right, well, that means that the tangent of theta, because theta is my unknown, equals 21 over 25. So again, how do I solve for theta? How do I undo a tangent? I do the inverse of the tangent. I do tangent inverse of 21 over 25. And when I get that, I get, now first of all, look to the question. Does my answer need to be in degrees or radians? It needs to be in degrees. Okay? So before you hit any buttons, make sure your calculator's in degrees. Inverse tan of 21 over 25 equals 40.03 degrees. Awesome. Questions? All right, we're going to go ahead and pause this for a second. I want you guys to work the following out on your own. All right, so everybody should have written the following relationship down. The tangent of 40 degrees equals my unknown height over 35. So when I take the tangent of 40 and then multiply by 35, what do I get for my height?
29.
Good, 29.37 feet. So what am I looking for when I say grade your quiz? On one like this, I would be looking for you to, 1, set up the proportion, 2, find the solution, and 3, remember your unit of measure. Now the previous screen where we had to do the inverse tangent, I would expect to see that step written down too, the inverse tangent, which you're actually going to put into your calculator. Okay? Questions?